Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, students of Senior 3 Chemistry class. You are most welcome for today's lesson. I think everybody is very fine and will enjoy today's lesson, all right? You are fine? Good. So we are continuing with the lesson 1 or unit 1 that we had started in the previous lesson. We had started looking at carbon and its inorganic compounds, all right? I think everybody remember where we stopped. We stopped by looking at diamond. We had started looking at one by one, the inorganic compounds of carbon. We had looked at diamond, all right? So we are continuing with another one, which is graphite. That is lesson 2. But under this, we are going to look at, you remember we have to look at the allotropic forms of carbon and their physical properties. That is lesson 2. So the objective, still we shall be able to name the allotropic forms of carbon and relate its properties to its uses. All right? So we are continuing with the lesson. I think everybody is ready with a pen, with a book, a notebook, and you're very attentive, and we start off with the work. All right? Are you prepared? Can we start off? Good. So today we are continuing with graphite. You remember we had talked carbon to exist in 2 forms. That is crystalline form and non-crystalline form. We said the crystalline form has got 2. Naturally, it exists in 2 forms. That is graphite and diamond. We had discussed about diamond. So we are continuing to look at graphite. All right? Remember, we have to look at the properties of these forms of carbon and relate them with their uses. That's the objective of the lesson. We look at that's why when we are introducing the lesson or when we are talking about the physical properties, you should be very attentive. Why? Because it is within the physical properties that all the structure makeup of these compounds that we get their uses. All right? We relate the physical properties with their uses. That's why you need to be very attentive. Good. So we start off with graphite. Look at the structure of graphite on the slide here. So you remember with diamond, we had said that diamond when each carbon is bonded to 4 other carbons. So no free electron. All the 4 electrons are used. But for the case of graphite, each carbon is bonded to what? Each carbon is bonded to only 3 carbons. All right? Only 3 carbons. And another electron is just free. It's delocalized. All right? So it is not attached to any particular atom, but belongs to the entire structure. That is the structure of graphite. Each carbon is bonded to 3 other carbons, and you find that another carbon is just left free. So it means that 1 electron is just free. The terms we use here, we say it has delocalized the electron, free movement of electron. That's where we shall find that structure gives it that function or that use of being conducting electricity. All right? So graphite, different from diamond, it has free electron. All right? It has free electron. That is the structure. So this gives it to be a good conductor of electricity since it has got delocalized electron. All right? So graphite exists as hexagonal. All right? The structure of graphite, if you look at the structure on the slide, if you look at the structure of graphite, it is hexagonal. You remember for the case of diamond, it is tetrahedral. But this one is hexagonal because the 1 carbon is bonded to 3 other carbons, as you see from the slide here. When you look at the slide, you see that the structure of graphite is very different from the structure of diamond. Why? We are saying for the case of diamond, 1 carbon is bonded to 4 other carbons, giving it a structure which we call tetrahedral structure. But for the case of graphite, one carbon is bonded to 3 carbons, giving it a structure we call hexagonal structure. And one carbon is very free, call that delocalized electron. So what does it mean? It means that since in conduction of electricity, we use a free electron. And for graphite, as you're saying, as we're talking about the structure, it has a free electron, delocalized electron, moving electron. So when there is a movement of electron, electricity can easily be flowing, all right? That's why diamond is different from graphite in a way that graphite can conduct electricity, but diamond does not conduct electricity since it does not have what? Who can remind that property? It does not possess a free electron, all right? So there is a weak bond between the carbon atoms. That is the weak bond, the van der Waals forces, all right? So that is how the structure of graphite is designed, different from the one of diamond, having a carbon bonded 3 other carbons, giving it a structure we call the hexagonal structure. And leaving one electron to be free, that gives it that property of conducting electricity. All right? Hope everybody now has picked the structure of graphite. So we can rush and see the physical properties of graphite. So remember in the objective. In the objective, we said we shall relate the properties with the function, with the use. So after looking at the structure of the graphite, so you have known, we're going to know the physical properties of graphite. So you relate the physical properties of graphite with the use of graphite, because it is from the makeup, the way it is made up, that will give it its function or its use. So one property is graphite is a soft, black, and shiny material with a glassy feeling. So what will it help it? We are going to see in the uses. So you have to master that. Graphite is very soft if you compare it to diamond. Remember, diamond, we said it is the hardest substance in nature. So for graphite, it is a bit soft. It is black and shiny. So it has that kind of grease, right? That is one property. So graphite is easily flakes off, can be removed off. Another thing, it has a relative boiling and melting point. So when you compare the boiling and melting point of diamond and graphite, you find that for the case of graphite, it has relatively high boiling and melting point, but it is not higher than that of diamond. So the density of graphite is 2.25 grams per cubic centimeter. So graphite is a good conductor of electricity. Why? We said graphite, it has got delocalized electrons from the structure. We have said it has free electron. That gives it that use of conducting electricity. All right? So another thing, it is opaque. Remember we talked of diamond being transparent. 2 words goes. Transparent and opaque, they mean opposite the other. When we say something is transparent, it means light can pass through. When we say something is opaque, it is dark. No light can pass through. All right? That is the difference. So graphite is opaque. So what are the uses of graphite? So remember from the physical properties, we are going to see the uses of graphite. One, as the subheading, the properties of graphite determine its uses. So if you have known in the physical properties class, from there you can tell the uses of graphite. One, it is used as electrodes in dry cells and fuel cells. This is because it is a good conductor of electricity. So when you get the dry cell, you know the dry cells? The dry cells that we use in radios, in watches, those dry cells. That black kind of, that electrode, the black kind of that is inside in the dry cells, that one is made of this graphite. Why? Because graphite is a good conductor of electricity. So you can ask again, why is it a good conductor of electricity? since it has free electrons, therefore, it can conduct electricity due to that movement of electrons. All right? So in the dry cells, in radio, you know, the dry cells used in radios, in watches, everywhere, they are made of graphite. The electrodes are made of graphite. Another use of graphite is that graphite is used as a carbonylator in the production of steel. It gives steel its strengthening characteristics. So another thing, it is used in advanced high friction applications such as car brakes. So you remember that. We have talked about the physical property of graphite, that graphite is a bit greasy. You know greasy? A kind of greasy. So when you get graphite and put it in car brakes, it can be used to stop what we call friction. You know, that kind of greaser. You get that graphite in a kind of greaser, you put in car brakes, then it stops what we call friction. So a car can move, the tires of the car can move freely without colliding among the metals in the car tires, all right? So it is used in car brakes due to that property of it being a kind of greaser. So it is used to make pencil leads. You know the pencil leads? So this is the pencil. There is that inner black kind of that we use for writing. That one we call it the pencil leads. So those pencil leads are made of graphite. Because remember, in the property of graphite, it is soft, it's black. So we use it for making, that property gives it a use to make what? To be used in pencil's leads. The pencil's lead is that black thing inside the pencil that we use for writing. All right? Hope that one is very clear. So from there, another property is that at higher temperatures, graphite can be used as, another use can be used as lubrication or lubricating in places of grease and oil. We talked about that. At higher temperatures, it can be used as oil or grease. In the production of paints and shoe polish, you said it is black. So you know these shoe polish, which are black, they are made from the graphite. It is used to make furnace linings, brushes for electric motors and generators. It is used as modulator in nuclear reactants. All right? So these are the uses of graphite, but letting them with their properties. All right? Remember the objective. We relate the properties with the uses. So any question there? I think you have seen how we relate the functions, the properties with the uses. So the structure, the way it is made, and its uses. All right? Good. So we are going to another thing. Look at the slide there. Look at the slide. Is everybody there? What do you guess this is? It is always there in your homes. What is that on the slide? What do you think it is? Anybody can tell? Yeah, it's charcoal. All right? It's charcoal. You are very right. Good. So this is among the non-crystalline forms of carbon. So we have finished looking at the crystalline forms of carbon. That is diamond and graphite. So we are talking about the non-crystalline forms of carbon, charcoal inclusive. So this structure is for charcoal. Think you know charcoal. That is charcoal. All right? The charcoal you use for cooking at home. These days they are not common because people use gas, biogas, this normal gas. So this is electric, whatever, power suppliers. So this is charcoal, the one you use at home. All right? So that's among the amorphous carbon or the non-crystalline forms of carbon. So we are saying that the non-crystalline forms of carbon are formed how? By decomposing other substances like wood using heat. All right? So charcoal and soot are examples of amorphous carbon. You know soot? You know soot? And this black thing, when you light a candle, there are black things that gathers. Those are soot. All right? So these are two. So under this, we are starting by looking at what we call the charcoal. All right? There are two types of charcoal. One, the wood charcoal and the animal charcoal. Both are formed as a result of what we call destructive distillation. What does it mean? Have you ever seen where they make charcoal? Let's talk of this normal charcoal, the wood charcoal. Anybody has seen where they make this charcoal? Yes? Yeah. In making charcoal, they gather wood. They go and cut poles of the wood, put them together, cover with soil, but they leave a smaller inlet where air will pass. So they put their dry grasses. Then they light. When they light, then it will burn slowly by slowly. It takes days, like 3 days. Why do you think they have to cover? Why do you think they have to cover the wood? Yeah? They cover the wood to limit the amount of oxygen entering. If they would leave it open like that, it will all get burnt and we form ash. We don't form charcoal, but we form ash. All right? So when they cover, there is what we call incomplete combustion. Incomplete combustion. Limiting. They limit the amount of oxygen that enters to prevent these woods from being burnt completely to ash. All right? So that one we call it destructive distillation. They destruct, they cut forest, they gather the poles, they cover, they introduce in fire, then a small amount of oxygen goes in, that is incomplete combustion. Then the woods get burned slowly by slowly. At the end, you form this charcoal, the wood charcoal. The same applies to animal charcoal. But the difference is that the animal charcoal are got from the animal bones. All right? These wood charcoal are got from the woods, as I've described, but the animal charcoal are got from animal bones. So they gather the animal bones, they burn them, then they get animal charcoal. It is also formed as a result of destructive distillation. All right? Those are two kinds of charcoal we are going to look at. All right? So we'll go and look at the uses, the properties as our objective. What are the properties or the physical properties of charcoal? One, charcoal is a black polar solid. Now, let's go back and see and prove it out. This is charcoal. This is wood charcoal, all right? So it is a black. I think everybody can see this. It's very black. All right? It is a black, among other properties, it's a black polar solid. It is soft and has a low density. If you compare charcoal with other these crystalline forms of carbon like diamond and graphite, for it is a bit soft. It can get charcoal, when you beat it down, it can get broken. But for diamond and graphite, it cannot. So it's a bit soft and has a low density compared to diamond and graphite among the crystalline forms of carbon, all right? It can be absorbed large volumes of gas and solids, right? It has a large volumes of gas and solids, all right? So the uses of charcoal. Charcoal is used as a source of fuel mostly in developing countries, like our country here. The country of Rwanda is trying to limit the number of people using, if not to finish out, if not to complete it, it is trying to limit the number of people using charcoal. That's why it has introduced in this using of gas. Days back, charcoal was very common. People used the charcoal and firewood for cooking. But these days, you see, some people are going on buying the using gas for cooking. So it's the government that is trying to limit or to remove that system of using charcoal. Why? Because one, when they are using charcoal, one, they are destroying the forests. What will it lead to? It will lead to air pollution. That is, when you're burning wood, that is carbon monoxide liberated in the atmosphere. Carbon monoxide carbon monoxide reacting with water to form carbonic acid, which is very dangerous. Another thing, the smoke that goes out can lead to respiratory diseases. So another thing is that as the forest is being destructed, it will lead to infertility of the soil, destruction of habitats for some unwieldy animals. So very many disadvantages. So the government came in and said, you know, instead of using charcoal, let us divert to another kind of fuel, that is gas. And we use gas for cooking. So charcoal is used as a source of fuel mostly in developing countries. Another thing, activated charcoal or charcoal that is finely powdered is used to remove smell gases in slaughterhouses, gas manufacturing plants, large air conditioning system, and airports. So when they get this charcoal and they crush it, all right, in form of powder, it is used in those areas to remove smell. All right? Good. So we have the lamp black. You know, the lamp black is used in making black ink, paints, carbon paper, and as ingredient in rubber tires. All right? The lamp black also is used in making black ink, paints, carbon paper, as also among the amorphous carbon. But before we go far, something we need to emphasize. Something we need to emphasize is that as the country is trying to stop the using of charcoal, all right? The using of charcoal. You know, the government has got this system of saying when we cut one tree, we plant 2 trees. Why? In case you need to use charcoal, in case you want to make charcoal, you cut 2 trees. I mean 1 tree, you plant 2 trees. Why? You replace the ones that you have cut. But you know, because we are human beings, some don't put it into practice. So what does it mean? That's why the government came out and emphasized that you should try to use at least the gas for cooking as a form of fuel instead of using charcoal. Though the country is still among the developing countries, but at least when you compare some years back with today, you find at least very many houses have got now gas. They're using gas instead of, and days back, in fact, the rich people could use charcoal. The poor people could use the firewood. So all that could lead into deforestation, which is very bad. So as we have been emphasizing charcoal as a form of carbon, don't put it into practice and say, you know what, teacher said charcoal is a good fuel, let's continue practicing that. No, no, no. You can divert to other forms of fuel, like that electric, whatever, that fuel, the biogas. Some of you lay animals at your place. So when you have animals, you can collect those, that feces and whatever, the cow dung and whatever, then you get what we call the biogas. It will help you for cooking. So don't rely mostly on charcoal. Charcoal, at the end, it will lead to very many other problems, like when you burn charcoal, as I said, you lead to those smoke that comes up, gives you, it can cause you respiratory diseases. The carbon monoxide, because we have said charcoal is made as a result of burning wood with limited oxygen, leading to carbon monoxide. Instead of carbon dioxide, we form carbon monoxide, of which when it reacts with water, it will form carbonic acid, which is a dangerous, carbonic acid coming back on Earth with rain, droplets as carbonic rain, which will affect the environment. That is, the houses made of marble, the skin can reach skin cancer, destruction of crops and plants. All that is a disadvantage of using charcoal, all right? So don't rely on charcoal. I've been emphasizing that. But we have seen how charcoal is made. And we have seen that charcoal is among the non-crystalline forms of carbon. So tell me, can any one of you describe the structure of the charcoal you're seeing there? Does it have a shape? I've been talking of diamond, graphite, diamond being tetrahedral, graphite being hexagonal. So talk of that. Which shape can you say? It has no shape. So we call those ones amorphous carbon or shapeless, in other words, non-crystalline. They don't have any shape. They don't have any shape. So making them to be called amorphous carbon. All right? As we are going to see other amorphous carbon. So we're rushing to the exercise. This is the exercise of today's lesson. So when you go back, you try to attempt these two numbers in your free time. One is to explain why graphite is used as a lubricant, whereas diamond is not. So you remember we said diamond is not used as a lubricant, whereas graphite is used as a lubricant. So, and we have given a reason from the structure of graphite. From the structure of graphite, we have seen the reasons, we have seen the structure of graphite and how that structure, you remember, we have said in our lesson that, remember the lesson, you go back and see. Go back and see the objective. You have to relate the property with the use, all right? The property and the use. So, which property does graphite have that makes it to be lubricant, to be used as a lubricant, all right? So concentrate on this work, then you try to answer these questions because we have talked about them. The last one is to give and explain the uses and properties of graphite. All right? So I think the lesson has been very interesting to everybody, and I've enjoyed your attentiveness. You've been good students as always, and I hope we shall meet in the next lesson when everybody is very fine. So do the small work I've left behind. Thank you so much. Bye.